In this video, I'm going to discuss about list. Let us consider a vessel in upright condition. So if we look the vessel from astern, say from here, so this side is going to be my starboard side and this side will be my port side. And let us consider the scenario on transverse direction. So let's say this is my center line. CL, this is the center line. Now we know the weight of the ship acts vertically downward. Weight of the ship acts vertically downward from a COG, and COG is a center of gravity. So we assume that there is a center of gravity here which is at the center line, and the weight is acting vertically downward from a COG. Well, this is our underwater portion if this is water line. So the force of buoyancy will act vertically upward through B. So we say this B is the center of buoyancy and the force of buoyancy acts vertically upward through COB. That is a center of buoyancy, which is nothing but the geometrical center of underwater volume. Well, here we assume that the COG is on the center line, so we say the vessel is up in upright condition. So the bottom line is the vessel can be upright if the COG is on the center line, which says that weight on port side, this is the port side and this is the starboard side, weight on port side is equal to weight on the starboard side, or simply weight is distributed symmetrically. Now let us consider the scenario where the COG is off the center line. So instead of a G, this is the COG here. Now instead of COG here, the COG has shifted here. Let us consider this scenario, and this can happen because of loading, because of discharging, or because of shifting. Well, the shifting in transverse direction, because in this direction, shifting in transverse direction. So this is an internal cause. Now if the COG is there a list movement is caused, and this list movement will incline the ship in transverse direction. There are two forces here and a movement is formed, and let's say the ship will incline, and now this B, let's go this way, this force of buoyancy has also moved and will come to pass through B1 only, because the geometrical center of underwater volume like this is also changed. So what we conclude here, that there is a G and G1, and wherever they cut, this is called M, and M is the meta center. M is the intersection of the center line and a new force of buoyancy. So we can say that transverse inclination of the ship when COG is off the center line, and that is called list. And it can be given by this formula, that tan theta is equal to GG1 by GM. It's a transverse inclination of the ship when the COG is off the center line, and this is because of internal factor, internal cause, and these causes could be loading, discharging, or transverse shifting, as I had discussed earlier.